Have you ever stopped to think that, at the very beginning of the universe, something as surprising as a giant of light could already exist? Imagine an object so enigmatic and powerful that, even with the universe still in its infancy, it already housed a black hole with a mass of 1.6 billion suns. Today, we will embark together on this cosmic journey to unravel how the quasar J0313-1806, formed just 670 million years after the Big Bang, has been defying all our expectations about the formation of black holes and galaxies, without immediately revealing all the details of this discovery that could change our view of the cosmos. To begin, it is important to understand what exactly a quasar is. These objects, which appear to be small sources of light amidst the vastness of the universe, actually represent the nuclei of distant galaxies where a supermassive black hole devours matter with surprising voracity. Around this black hole, a disk of superheated matter forms, emitting intense radiation, making the quasar one of the brightest sources in the cosmos. Just imagine a process so violent and energetic that it can outshine the galaxy in which it is located, leaving us with an almost surreal image of the universe's infancy. A team of astronomers from the University of Arizona has made a discovery that literally takes us back in time. The quasar J0313-1806, located 13.03 billion light-years away, the most distant ever recorded. In a scenario where the universe was only 5% of its current age, finding such a massive black hole is like discovering a precocious millionaire in the middle of a village of ordinary people. This discovery not only surprises us with the magnitude of the object, but also forces us to rethink the mechanisms that allowed such accelerated growth shortly after the Big Bang. One of the most impressive aspects of this discovery is the speed at which the superheated gas is being expelled from the vicinity of the black hole, reaching about 20% of the speed of light. This phenomenon reminds us of how chaotic and intense the primordial environment was, with cosmic winds capable of shaping and even interrupting the formation of new stars. To illustrate, think of a blowtorch that, when releasing such a powerful flame, manages to sweep away everything around it. It is precisely this energy, released on unimaginable scales, that prevents the cold gas from clumping together to give rise to new generations of stars in the host galaxy. And speaking of star formation, the quasar J0313-1806 reveals a scenario where stellar activity reaches surprising levels. While our Milky Way produces, on average, 1 solar mass per year, the galaxy that hosts this quasar is forming stars at a rate about 200 times greater. This drastic difference not only highlights the intensity of the processes that occurred in the early universe, but also shows us that, at such remote times, galaxies were experiencing a true growth boom, with black holes and stars in constant interaction and evolution. Traditionally, scientists believed that black holes formed from the collapse of massive stars or the merger of dense star clusters. However, the discovery of J0313-1806 breaks this paradigm, as the mass of this black hole is so exorbitant that conventional models cannot explain its rapid growth. The researchers suggest that, for it to reach such magnitude in such a short time, the seed of the black hole must have originated from a direct collapse of enormous quantities of cold primordial hydrogen gas, a process that completely escapes the methods we know for star formation. This new mechanism, which allows gas to collapse directly into a supermassive black hole, is a game-changer in cosmology. It explains not only how such a massive object could form so early, but also how the energy released by this process may have impacted the evolution of the first galaxies. It is as if the universe has its own shortcuts to create complex and imposing structures, challenging the notion that everything must follow a slow and gradual process. This revelation invites us to look at the cosmos with a new sense of wonder and curiosity, recognizing that there are still many mysteries to be unraveled. In addition to the instruments we already know, astronomical technology has advanced so impressively that today we have state-of-the-art sensors and detectors capable of capturing incredibly subtle signals from the cosmos. For example, innovations in spectroscopy and infrared imaging techniques have revolutionized our ability to study the early universe, allowing us to identify traces of elements and energy with astonishing precision. With the help of artificial intelligence algorithms, it is possible to analyze massive amounts of data in a matter of hours, extracting patterns that, until recently, would have gone completely unnoticed. This technological advancement not only broadens our view beyond known borders, but also strengthens international collaboration between research centers, creating a global network that drives discoveries in a collaborative and dynamic way. Each advance in this field is like adding a new piece to a cosmic puzzle, allowing us to reveal, in ever clearer detail, the hidden history of the early universe. On the other side of the coin, the discovery of quasar J0313-1806 reinforces the idea that the universe is a field of constant surprises, where the unexpected can transform our understanding of cosmic processes. Instead of viewing this evidence as an obstacle to traditional models, we are invited to see it as an opportunity to rethink and expand our scientific paradigms. This constant renewal of knowledge encourages us to question what we thought was definitive and to seek new answers to mysteries that have long defied our logic. The fact that a single object is capable of turning the way we understand the formation of black holes and galaxies around shows us that science is in a state of perpetual evolution, where each discovery paves the way for new hypotheses and investigations. This dynamic of questioning and reinvention is what makes astronomy so fascinating and essential to the advancement of humanity, inspiring generations of researchers to courageously explore the confines of the unknown and contribute to the constant rewriting of the history books of the universe. So, everyone, what did you think of this journey through time and space? Isn't it jaw-dropping to see how the quasar J0313-1806 is rewriting the rules of the formation of black holes and galaxies in the early universe? This discovery not only amazes us with the speed of cosmic processes, but also inspires us to believe that the unknown is always waiting to be revealed. If you were as fascinated as I was and want to continue unraveling the mysteries of the cosmos, like the video, subscribe to the channel and activate the bell so you don't miss any news. Let's explore every corner of this incredible universe together.